Hello everyone. So let's start solving today's Leetcode daily challenge question. So the question is path with maximum probability. So you are given an undirected weighted graph of n nodes, okay, zero index, represented by an edge list where edges of I is equal to a comma b is an undirected edge connecting the nodes A and B, okay, with the probability of success of traveling that edge is this, okay. So we are given with the two nodes start and end. Find the path with the maximum probability of success to go from start to end and return its success probability. Okay. So if there is no path from start to end, return zero. Okay. Take. So if we see this example, n is 3, so there are 3 vertices. Ages are from 0 to 1, 1 to 2, and 0 to 2. From 0 to 1, the probability of going from 0 to 1 is zero point 0.5, from 1 to 2 is zero point 0.5, and from 0 to 2 is zero point 0.2. From 0 to 2 and 2 to 0 are the same, okay, because it is an undirected graph. So we have two paths. One is the start is 0 and end is 2. So we have two paths, either go from 0 to 1 and 1 to 2, or 0 to 2. If we go on this using this path, so what will be our probability? Okay, because we have to maximize the probability of success to go from 0 to 2. So if we go this 0 to 2, then we have probability zero point 0.2. If you use this path, then it will be zero point 0.5 into zero point 0.5, that is 0.25. So 0.25 and zero point 0.2, which is greater? 0.25. So the answer is 0.25. So why we are multiplying? Because when you do probability topic in mathematics, so if there is a and, then we multiply, okay. So we are using this and this, so that is why we are multiplying. So basic take, okay. So if we see this example, now from 0 to 2 we have zero point 0.3, and from 0 to 1 and 1 to 2 we'll get 0.25. So which is greater? 0.3. So our answer is zero point 0.3. So in this example we have to go 0 to 2. There is no path from 0 to 2, so it is returning 0, okay. So we will solve this example using our graph method only. So here what we will do is we will first find, okay, we will find from 0 to 1, from to 2, what is the, I mean, from the start, okay, from start, from that start, what will be the maximum probability to reach 1 or reach 2, we will find, and at the end whatever we will be getting, okay, till um, till the end node, okay, because we want end node to reach to from 0, what is the maximum probability if we found, we can return it, okay. So first let's take an array. We'll take double because in the question also it is given double, okay. Here are the ages, these are the probability of success, and this is basically from 1 to 2, okay. The probability of success is zero point 0.5, from 0 to 1 it is zero point 0.5, okay. Then now max probability is equal to new double of n, okay, size n. Now what will be max probability of start node is, it is 1, okay. To this is a start node. To reach this start node, from the start node, what is the probability? It is 1 only, right? So this is our initialization. Then we have to check for all the vertices. So we'll use one loop, and then, okay, then we will browse all the ages for what, for check for updating our maximum probability, okay. So from int I is equal to 0, I is less than ages dot length, it should be j, okay, j plus plus, Here it will be j and j. Okay. Now, what is ages? Okay, age of. Let's take two. This is a u and this is a v. Okay. So from u we are going to v. Int u is I. Okay. It is j of 0 and int v is equal to j of 1. Okay, that means in u it will be 0, in v it will be 1. From 0 to 1 we are moving. Okay, so if we are moving from 0 to 1, we have two possibilities that, okay, how to calculate. Okay, now if I'm moving from 1 to 2, how I can calculate the probability from 0 to 2, as as we are coming from 0 to 1 and 1 to 2, we are multiplying, right? So this is the 0.5, this is the probability of reaching 1. Okay, the reaching 1 into the current probability. Okay, so what is the current probability? Is double probability is equal to what? It is success probability. Okay, of what? Of I. Okay, to reach the current node, we have success probability of I. This we got. Now we will check from go from 2 to 1 or 1 to 2, which will be the best, and we will update that maximum probability. So we will check if our if what max probability of u into probability, if it is greater than max probability of v. Okay, so that means max of u this into this. Okay, it has its own probability of coming from 0 to 2. Okay, initially it will be anyway 0. Okay, but every time we are updating, so its actual probability, if it is less than coming from here, so we will update it max of prob v is equal to max prob of u into probability. Okay, now we are updating this. Now we also have to check what? Check and reverse way. So if we copy the same, okay, here v and here u. So if we are moving from, okay, because it is undirected, we are checking both of the condition. So if we are moving from v to u, then I can check this v probability into this. If it is less than this, then we can update what? We can update as we want to maximize. So we can update this max probability of v into prob. Okay, so this we can do, and at the end we can return what? Max probability of end node, because max probability of I means to reach that I, what is the maximum probability. Okay, now here what we have done, j used I, then u v. Okay, so here what happens, let's say mm, I plus j, yeah, we are correct. Okay, let's say if the values are not updating. Okay, so for I is equal to 0. Okay, from I is equal to 0 to 1, it has updated, and we got one stage where where the values are not updating. That means that is the optimized one. So what we can take, we can choose, we can take a boolean. Okay, boolean, let's say updated um, so line number 11. So age of 0 and 1, which is the line at line number 11. Ages of j, and it's 0 and it's 1 because it is a 2D. So it's 0 is 0 and 1. I mean the first element, this is u and this is v. Okay, let's take updated initially as a false. Then when we are updating, update at what is the updated is equal to true, and here also make updated is equal to true. Okay, now next, if after this iteration, if updated is, if it is not updated, that means we can just return. Okay, if it is not updated, then we will just break the loop. Okay, instead. So let's wait for this test case to run. This j we have updated, right? So we have used j variable and ages of j of 0 and 1. Okay, let's give it as a 1.0 as it is double. So what is the one index 1 out of bound for length 1 at 12 at here. Okay, success probability of I. Okay, we are taking I only, right? From I is 0 to I is less than n minus 1 and I plus plus. Other, we are not updating, right? So just let me run once again. Okay, wait. So we are taking here I. Okay, but we have to consider this, right? Yeah, this. So this will be j. So if we are moving from 1 to 2, then we will consider this as the current probability of moving 1 to 2. So this will be j instead, not I. Okay. So here we made a mistake that here it should be j, not I. I just to reach that node, what is the maximum probability? Okay. Yeah, I will run now because we have changed this uh, I I to j, because j is what moving from this, right? Let's say j is here. So from moving to move from 1 to 2, what is the probability, current probability, this. So we will use j. Okay, because j is here 1, here it will be also 1, not the I, because I is we are using just for that node. To reach that node, what is the maximum probability. Yeah, you can see now accepted. Okay, and also we have used this updated to optimize this solution as if the values are not updating. Okay, here if it is not updating, that means we have got our solution. So we will just stop it. Okay, so we will break it. So let's submit it. Yeah, now I can say accepted solution. So in this way we can solve this question. Okay, this is the one of the way to solve the question. You can use the other ways also. So if you feel this video is helpful to you, please like this video, subscribe my channel. Thank you so much for watching this video.